Check. My name is Sam Shields. I am a PhD candidate at UC Santa Cruz. Today I'm going to be talking about simulating director-based dynamic balancing systems for different player-centric strategies. Did this work with Eddie Melcer, and apologies in advance for the terrible Keanu Reeves impression that's coming up. Quick anecdote for context. Growing up, the third place for my neighborhood was whoever had a GameCube, 4 controllers, and Smash Bros. Melee. A lot of us, or at least a small subset of that group, started getting more and more competitive, and we started practicing non-obvious strategies like wave dashing. In other words, we got a bit sweaty. Both the tournament scene and the at-home scene we're both really excited about Super Smash Bros. Brawl, and as we got more competitive, we got kind of relegated to the tournaments while everyone at home didn't really want to play with us in Melee. But as Brawl was coming out, both scenes were pretty excited about this. And when it was released, everyone at home started picking up Super Smash Bros. Brawl. But Brawl introduced some forced randomness that was not very well received by the tournament players. And they indeed quickly switched back to Melee as their game of choice for competitive games. And so before I go further, and with that anecdote in mind, we might ask the question, what even is balancing? There is a ton of unaligned definitions about this term. They generally touch on fairness. We did a literature review of over 100 papers, tons of different dimensions, but they all talk about how do I feel after I play a game experience. It's emergent. Unfortunately, we don't get a nice little knob that allows me to tune balance. We have to do a bunch of different complicated things. And balance is also dependent on the players playing your game, your goals of your designer, what kind of balance do you want your players to experience, and the impacted game elements and systems involved there. And I have two user statements here that kind of demonstrates the differences in these types of balancing strategies. So one, I might want players of different skill levels to have equal chances at winnings by tweaking scoring systems. Or I might want to have players of equal skill levels to have equal chances at winning by rewarding mastery of game controls. And so with that in mind, you might ask the question, is balancing different for every game and system? And my answer is yep. As a designer, the top one, you can see from our preliminary taxonomy under revision, even under the idea that we're all talking about competition, if my players have differential skill, as a designer, I might have an entirely different balancing strategy than if my players have a similar skill. And indeed, when we look at games, we can see stuff like Mario Party, where my concept of balance in that game means I want to have a families, small children be able to compete with their parents and not feel like they're going to get stomped every game. Likewise, in Counter-Strike, I want that to be a fairly evenly skilled trading between wins and losses because those players practice really hard and they want to demonstrate their skill in that environment. And so then you might be asking, surely single games have a single balancing strategy? And my answer to that is nope. Even in Smash Bros. Melee, there are settings and controls you can use to tune the game for these different audiences. So you can increase the randomness by introducing items, or you can decrease it by saying final destination only, foxes only allowed. So we can use this working definition, which is game balance is dependent on your audience's perception of fairness. It's driven by your goal experience as a designer. It's tied to specific or interacting sets of game systems, and it's contextual to the game environment. And so let's test and apply this. There are a lot of balancing strategies. There's two large buckets I like to talk about. One is static, so things done at design time, and dynamic, which are systems that operate at runtime. There's tons of ways to achieve balancing. Machine and reinforcement learning, playtesting design loops, analytics, and from what I've gathered from a lot of people in my own experience, like a lot of spreadsheets. And it can be done in different ways in the same context and system. You can target different audiences, or you can target different elements of balance. And so our question for this case study is, can we confirm that balancing has different manifestations in a single game context and implemented system? And we're going to use this neat little simulation called FighterDDA, or dynamic difficulty adjustment, and the AI director pattern. And so what is the AI director pattern? It is a type of experience manager. It frequently has to do with difficulty or changing the experience narrative of a game. But the key components of it is you have some game state, you're observing that game state for key elements, you have acting triggers to decide what should be or when should a system be changed or a state should be changed, and you have a policy which dictates how that state should be changed over time. You modify the game state, wait for results, observe it again, and continue. And so the system we're presenting here is called FighterDDA. It's a test bed based on turn-based role-playing games. They're a really well-established genre. They're used today. Clara Obscura, famously, a really great game this year, uses a similar system. And the game has two adversarial teams. The game ends when all characters from one team is defeated. We have an AI director, but we have multiple strategies targeting multiple personas running in the background. And the simulation mode runs headless at a high volume with gameplay data logging. Here's some quick pseudocode, kind of just running through the core loop. You'll see highlighted elements from a Final Fantasy VII screenshot, roughly showing what's happening at each of these code steps. But basically, we have some sort of speed meter. When it fills up, you can perform an action, throw it on the queue, execute that action, and most importantly, you have a director at the end who's looking at that game state and executing the appropriate balancing strategy. I also included a screenshot from Pokemon. That is the Sandstorm effect, and this is just a demonstration that these games not only target player stats, but sometimes there are environmental effects that affect things like both players' defenses or damage taken over time. And so we have these two directors in this system, and they're looking at those earlier user statements where we want to see differential skill levels and we want to see similar skill levels, even in the same game environment, even in the same combat system. Can we hit those two user personas using this dynamic difficulty system? And so in the differential skill condition, we want to make sure that if we have two differently skilled players, we're closing that win gap between them, and we're moving up the length of the game, moving up the draw ratio. If there are similar skill levels, we want to be able to control difficulty. We want them to say, hey, I feel skilled. How long is this game going to last? Or how short is it going to last? How punchy is it going to be? And so we have these two directors implemented in different ways. The differential skill levels looks at the state of characters and accordingly applies stat buffs and nerfs to try and push one team ahead of the other. And in the similar skill level, similar to the Sandstorm effect we just talked about, it looks at the predicted game end and then applies environmental effects to try and move that gap closer. In both cases, we're looking at a heuristic that looks at the magnitude and difference between the game state's ideal ending and the current state, and then applying changes accordingly. So who's playing? It's a headless simulation. We obviously don't have real players involved, but we do have some utility agents. The optimal agent selects actions that are most likely to kill or save one of their teammates, or kill an opponent or save one of their teammates. You might think of this as an expert player. We have a random agent, which effectively selects things at random. This might be a new player. And then we have the griefer. It's not quite a bad player. Instead, they do things like heal instead of attack, so they just draw out the game, and it's like obnoxious. And so what happened? So when we ran this simulation a bunch of times, we found that we were able to have one director condition effectively close this gap, bump up the draw rates, and make sure that there's at least a slight movement, indicating that we have some ability to make sure that we can close these gaps in this differential skill condition. We also validated that in the difficulty condition, that director can change the length of the game to try and make that game difficult for those more competitive players who might want a more difficult experience. But this is my favorite slide, and my dude, but why? Game balance can make or break your game. It's key to long-term success. This has been repeated over and over by game designers and directors everywhere. And game balance, importantly, has no one-size-fits-all approach, but it needs to be tweaked for different audiences and different games. And while full automation of balance might be a little unrealistic, my philosophy is that if we can just automate like 5 to 10% of the design, development, playtesting cycle, that's a huge saving in time and money. Think about all the playtesters, engineers, and designers involved in this process that occurs throughout every part of your game development lifecycle. If you can chop off 5% of that, think about how much many man hours or person hours that you've saved. And also importantly from this case study, we've learned that a single architecture for balancing can fulfill multiple audience goals, which means you can actually have a simplification in your balancing strategy, even if you're targeting different audiences. I can still have a relatively similar director target these different audiences and drive success even for fundamentally different director goals. So I Have my question slide up here, which if you want to see my other works, wait 5 minutes. And special thanks to all of our funders. And if you want to catch up or collaborate, my socials are on the right. But I also wanted to do something fun. While I take questions, I want to give a brief photosensitivity warning because this will have a lot of text scrolling very fast. But while we're talking, I'm going to run some of these simulations and I'm going to show some of the differences in these directors as we answer questions. And luckily it takes a few seconds, so I'll have a break to talk, but I'm free to start taking questions. And this is running 1,000 games right now. And it's slowed down, so maybe I didn't need the warning. Hi. Yeah. Yeah. I'm so glad you asked this. So a common theme in the balanced literature, and there's actually documented results about this, is the concept of believability. So if I know a director is operating in the background and changing things for me, it actually negatively impacts my self-esteem and feelings of performance. So you have to do this subtly. And so I think an interesting result that could be explored next, and something that we actually plan on doing, is if you have the director visible, and I have this like weird eldritch thing that will represent it, does that impact believability and change things? So I think there is already some history of experimentation on the subject, but it has been noted both in the industry literature and the academic literature that being subtle in how you do this is really important. And ideally, in true competitive environments, this is brought down to a minimum. Um, yeah. Yeah, that's a great question, and in fact, something I want to handle eventually. So we picked utility agents because it's as a grad student, they're not really resource intensive. They're computationally fast. You get really dynamic behavior out of them, even at low levels of implementation. But something that it doesn't cover is players learn over time. They get better at games, and so having like say a learning based agent or something like that might be really important to actually justify the success of this system and bring you closer to the target in terms of talking about real players. So excellent point, future work, but I think it would easily slot in. It's just an agent selecting actions at the end of the day. Oh, yeah. Yeah, so we were very careful in making sure that the third persona wasn't like really bad player, but it was griefer. Specifically because like that's what well, if you're unfamiliar with the term, a griefer is someone who tries to make the gameplay experience bad for others. And so that agent is basically negatively impacting the experience and trying to draw out games, and is just kind of obnoxious and tiring. And so I can go back to the results slide. I can also show during the demos, which might be easier. And even up on the screen, this is between an optimal and a new player, and you can see that the optimal player is winning very, very frequently. And this is with a difficulty director enabled, not the one that's going to try and collapse win rates. I can run the other one if I have time at the end of my poster talk. So wait 2 minutes. But yeah, it's a question of how you write the agent more so than the system. The system will handle it based on performance. The game state's not looking, it doesn't have visibility into the mind of the agent itself. It only has visibility into the game state. Does that make sense? Yeah.